Welcome to the world of text-to-text generation. In the field of NLP, text-to-text generation stands out as a versatile framework. It refers to transformation of an input sequence or text into an output sequence, ideally making the information more useful, detailed, or rephrased. This task encapsulates various NLP subtasks such as translation, summarization, question answering, and more, all under one unified framework. Consider a simple question: how can I become more healthy? Our text-to-text model takes this query and furnishes an expressive and detailed answer. It suggests practical steps ranging from balanced diet to stress management. This transformation from a question to a comprehensive answer exemplifies the model's ability to generate information-rich content from a seed idea. To begin our journey into text-to-text generation, we first import the essential library. As you can see on the screen, we are making use of the pipeline function from the Zenova/Transformers package. With the library in place, our next step is to set up the generation pipeline. For this task, we are utilizing the text-to-text generation model from Zenova. Specifically, we are leveraging the La-Mini FLAN T5783M model variant, known for its adeptness in converting input text to expressive and detailed output. We feed the model with a query: how can I become more healthy? We have also set a limit restricting the response to a maximum of 100 tokens or words, ensuring the answer remains concise yet informative. And finally, our model returns, emphasizing the importance of balanced diet to the significance of relaxation techniques. The model presents a comprehensive roadmap to better health. This example showcases the power of text-to-text generation, converting a simple query into a detailed answer. Now to the implementation. Let's go to our web page. Let's select the text-to-text generation page. As you can see, we have two subtasks. Both are using the same model. Then I'll go to Visual Studio Code. I will open the text-to-text generation page, and we will start as usual by creating the script tag. It is of type module because we want to use the import statement. Now inside the script, we import the pipeline from the URL. Of course, as every time, the URL we can get it from the Transformers page installation, and then you go to this place where it contains this URL. Back to Visual Studio Code, the next step will be to attach the pipeline function that we imported to the window object. This is because variables inside a script type module are local. They are not visible outside the script tag. So in order to make the pipeline available globally, we attach it to the window object. Now we go down to the initialize model. Of course, here we are launching or firing the pipeline with text-to-text generation as the task, and here this is the name of the model. Now let me copy this model to show you where I get it from. So I'll go back to the transformer page. I will go the pipeline API, and at the very bottom we can see the NLP tasks. Now this one is text-to-text generation. So if we look at the models here, if we search, you find this is the model that we are using. Back to the code. The next step will be to generate the text inside the function that handles the first button. So the first step will be to get the input from the input field. The second step will be to launch the generator that we imported above. Of course, it is a sync method because we will use await, and we are using await because the generator takes time to make its work. So we need to wait for it until it finishes. We pass the string, and we also pass a JavaScript object with a key maximum new tokens of 100 to make sure that the generated text is only 100 tokens or words. The output will be stored in the result. Let's now convert this result to a string and output it to the output area. Now we should be ready to test this. So you can see that here I have this question: how can I become more healthy? I'll do generate. Now this takes a little bit of time, so similar to what we did in summarization, you may need to disable the user interface during the call and change the mouse to wait. Now it took a little bit of time, but now as you can see, we have got the plan how to improve your health and live better life, which is, I think, impressive given the model. Okay, the next one, let's generate a poem. So I'll go back to the code. We will use the same model. So we will just get the input from the text. We will call the generator. We will pass some custom settings. So the max new token, we will set it to 200. So 200 were to be generated. The temperature can be between 0 and 2. 0, very deterministic, unlikely to give a new answer, while 2 is more random, and it is more likely to produce new things. So the temperature with a poem will be a little bit high because you want creativity. The repetition penalty, it is from -2 to +2. -2, it allows for repeating the word, while +2, it prevents the word from being repeated again and again. And I think we need that for the poem. And finally, the number of returns, we will have 3 returned options from the model. Okay, so let's now output the result to the output area after converting it to us. Let's go to the web page and let's press on generate. It will take some time because converting text to text is a lengthy operation. Okay, so this is the poem that it has generated about cheese. Again, given that it is just a model, a machine learned model, these things are impressive.